This is the solution key for Melham's Exam 3 for Math 222 Pre-Calculus. Number 1, we have the zeros as -2, 1, and 5. So -2, 1, and 5. And behavior when x goes to infinity, y goes to infinity. You have big number times a big number times a big number is a big number. When x approaches negative infinity, y approaches negative infinity. You have a negative big number. You have a negative big times negative big times negative big is a negative big number. And these are all multiplicity 1, so each one will cross the x-axis. So up and then down and up. Number 2, it's a cubic polynomial, so degree 3. 0 of multiplicity 1 at x equals 2, and 0 of multiplicity 2 at x equals 4. So that gives me x minus 2, x minus 4 squared. And you know p of 1 is equal to 3, and I put a k in front. So there's 2 multiplicity 1, and there's 4 multiplicity 2. So to find k, p of 1 is 3, so 3 is equal to k times 1 minus 2, 1 minus 4 squared. Okay. Do the work, this comes up to be 3 equals negative 9k, k is equal to negative 1/3. So p of x is negative 1/3 times x minus 2, x minus 4 squared. Number 3, factor the polynomial. You're already told that p of 1 is 0. So once you bring it down to a second degree equation by plugging in the 1 and factoring with x minus 1, you've got a quadratic. Okay, so using synthetic division on 1, 1, negative 5, 8, negative 4. 1 times 1 is 1, negative 4 after adding, negative 4, 4, negative 4, 0. So this is x minus 1, x squared minus 4x plus 4, factoring into x minus 1, x minus 2 squared. Number 4, determine the possible rational zeros of the function. Do not actually find the zeros or factor it. Possible rational factors are plus or minus factor of 5 divided by factor of 10. So plus or minus factor of 5 divided by factor of 10. Factors of 5 are 1 and 5. Factors of 10 are 1, 2, 5, and 10. So now you take each numerator and divide it by each denominator. In other words, you take 1 and 5 and divide it by 1. Then you take 1 and 5 and divide it by 2. Take 1 and 5 and divide it by 5. 1 and 5 divided by 10. So dividing by 1, plus or minus 1, plus or minus 5. Dividing by 2, plus or minus a half, plus or minus 5 halves. Dividing by 5, plus or minus 1/5, plus or minus 5/5. But 5/5 is 1. We already have that, so we can cross that out. And plus or minus 1/10, plus or minus 5/10. But 5/10 is the same as a half. That's already in this. Okay, so reviewing the list, we have plus or minus 1, 5, 1/2, 5 halves, 1/5. Number 5, okay, domain, all real numbers except whatever makes the denominator 0, that would be 4 and negative 5. So domain is all reals minus the set consisting of 4 and negative 5. Okay, intercepts, when you plug in 0, put a 0 there, you get negative 6 over negative 20. Negative 6 over 20, which is negative 3/10. So 0, comma, negative 3/10. For x-intercepts, set y equal to 0. Y is equal to 0 when the numerator is 0. So what makes the numerator 0 are negative 2 and positive 3. So negative 2, 0, 3, 0. Horizontal asymptotes. If you multiply it out, that's going to be x squared plus blah, blah, blah. The bottom is also going to be x squared plus blah, blah, blah. So in the long run, the ratio will be 1. So horizontal asymptote y equals 1. And vertical asymptotes are x equals 4 and x equals negative 5. Number 6, f of x is 4 over x plus 1. X is not allowed to be negative 1. So that leads us to a vertical asymptote. Okay. When x approaches negative 1 from the left, y approaches negative infinity. So if I plug in negative 1.01, I have 4 divided by small negative. That's large negative. X approaches -1 from the right, like -0.99. -0.99 plus 1 is a positive number, so y approaches infinity. Okay, vertical asymptote is x equals -1. Horizontal asymptote, the bottom is degree 1, the top is degree 0. The bottom is going to win. For x super big, positive or negative, the function approaches 0. So it looks something like this. This happens to be 0, 4. You can get that by here. Okay, 7. Square root of this big thing has to be greater than or equal to 0. So I just set this to be greater than or equal to 0. That gives us -2, +2, and 4. They're all closed circles because they will all say 0 is greater than or equal to 0. For instance, if I plug in 2, 2, 2, 2, 2 right here makes this a 0, and 0 is greater than or equal to 0. It's greater than or equal to 0. Okay, region 1, 2, 3, 4. So over here I put -3, 0, 3, and 5. We plug in -3 plus 2 is a negative. -3 minus 2 is a negative. -3 minus 4 is a negative. 3 negatives makes a negative. Is a negative greater than or equal to 0? No, that's false. Do not shade that in. 0. 0 plus 2 is positive. 0 minus 2 is negative. 0 minus 4 is negative. Positive times a negative is positive. Is a positive greater than or equal to 0? Yes, that's true. Shade in region 2. Region 3. 3. The number 3. 3 plus 2, positive. 3 minus 2, positive. 3 minus 4 is negative. So positive times a negative is negative. Is a negative greater than or equal to 0? No, it's false. Do not shade in region 3. And finally, region 4, 5. They're all positive. 5 plus 2, 5 minus 2, 5 minus 4, they're all positive. Multiply them together, you have a positive. Is a positive greater than or equal to 0? That's true. Shade that region in. So we have bracket -2, 2, bracket union, bracket 4 to infinity. Okay. Number 8. F of x equals x plus 1 to the 2/3 minus 2. Sketch label intercepts and asymptotes. So first I look at g of x equals x to the 2/3, which is the cube root of x squared. This is going to be an even function because of the square. So I plug in a positive number and its corresponding negative, you're going to get the same answer. So 0 plus or minus 1 plus or minus 8 because I have to end up in the cube root. Okay, 0 gives me 0. Plus or minus 1, whether you have 1 or -1, when you square it, it's 1. Cube root is 1. Okay, and plus or minus 8. If I plug in either a positive or negative 8, when you square it, it's 64. Cube root of 64 is 4. So I have, for the green function g, just this one, 0, 0, 1, 1, 8, 4, -1, 1, -8, 4. Okay, then the f with the -2, just bring it down 2 units. And x plus 1 means move over 1. So 0, 0 moves to -1, 2. Looks like that. Okay, looks like there's no asymptotes. Okay, for intercepts, when x is 0, put a 0 here to get 1 minus 2, which is -1. For y equals 0, I'm solving this. So 0 equals x plus 1 to the 2/3 minus 2. Add 2. Raise both sides to the 3/2 power. Cancel this out. And then subtract 1. So that gives me 2 radical 2 minus 1. 2 to the 3/2 power is 2 radical 2. Okay, this is like 2 to the first power. This is 2 to the half. Add the exponent to 2 to the 3/2. All right, so 2 radical 2 minus 1, comma 0. That's over here somewhere. And roughly that's about 1.8. Number 9, simplify 2 over 3 minus 4i. Multiplied by the complex conjugate, which is 3 plus 4i. So multiply the top 6 plus 8i. This is a squared minus b squared, so it's 9 minus 16i squared. Minus 16i squared is -16 times -1, which is plus 16. 9 plus 16 is 25. So 6 over 25 plus 8 over 25i. And finally, number 10. We're given that x equals -2 plus 4i is the solution of this equation. So automatically its conjugate, -2 minus 4i, is a solution. And incidentally, I noticed when I plug in 1, you get 0. 1 plus 3 plus 16 is 20 minus 20 is 0. So we have all the solutions already. They're going to be 1 and negative 2 plus or minus 4i. Okay. And if you want to check 1, 3, 16, and negative 20, do the synthetic division 1, 1, 4, 4, 20, 20, 0. That's x minus 1, x squared plus 4x plus 20. And if we do the quadratic formula on this, we do get indeed negative 2 plus or minus 4i. Okay, so anyway, the answer to this problem is 1 and negative 2 plus or minus 4i. All right, so these are solutions for Pelham's Math 222 exam 3.